Hello friends, this video on DNF block elements part 8 is brought to you by examfear.com. No more fear from exam. Now here this is actinium. This is discovered in 1899. This is radioactive. In fact, now we will see most of the element as radioactive only. This is again soft silvery white that glows blue in the dark. And this also reacts with oxygen, but it forms oxide coating. This forms oxide coat. That is my actinium oxide, and this prevents further oxidation. This is again found in trace in uranium. Okay, and due to scarcity and the high price, this is not much used in the industry, but it is used in cancer treatment. Okay, the next element is RF, that is Rutherfordium. So I'll just skip it fast because not much use of these guys. The Rutherfordium discovered pretty late, 1960, by Russia and California. And this IUPAC name Rutherfordium was given in the honor of Rutherford, famous chemist. Not much use, all radioactive. In fact, Dubnium, this is named after the city Dubna. It is a city in Russia where it was discovered, or where it was produced, I'll say, because it's all artificial. These elements are all artificial, and this is radioactive. It was produced in 1997, pretty recently, and this IUPAC name Dublin was given. The next is Seaborgium. This is again named after famous American chemist who discovered a lot of elements, radioactive elements. That is Seaborg. Yeah. And this was again synthesized in 1974. In fact, this was synthesized in Dubna also, and it was synthesized in California also. We'll see that most of these elements actually Russia and America both had discovered this independently in the same span of time during their Cold War, because the nuclear technology was the hot technology there, and Russia and America both wanted to have this nuclear power. These were all synthesized elements. Same thing, Boreum. This is named after Niels Bohr. This was also synthesized, radioactive, and this was synthesized in 1981 by, and how did you synthesize this? For example, this Boreum, atomic number is atom 107. So in fact, this was synthesized by targeting bismuth with the nuclei of chromium. So when you target bismuth with chromium, it looks like at very high temperature, you get this Boreum. In fact, it's very, very highly radioactive. In fact, the most stable isotope of Boreum has a half-life of 60 seconds. And since they have very, very small half-life, it's very difficult to understand their chemical behavior. But most of these are the radioactive metals used in the nuclear plants, or sometimes the nuclear bombs also. Hassium, again, this is also synthesized. This is named after a German state, Hesse, because it was discovered in the lab, and this lab is located in this Hesse location, and this is called hassium. Again, this is also radioactive, and if you see, the most stable isotope of this has T half of almost 9.7 seconds. The other isotopes may have the T half of half seconds also. Right? Very, very highly radioactive, and this was discovered in 1984, not very old, by bombarding lead with accelerated iron. So lead 208 with accelerated iron 58, and with this it produced 3 atoms of hassium. Right, this was produced in the GSI lab, Hesse, Germany. The next is Nerium. Again, this is also produced in the same lab, XII lab, Germany, again in the same 1984. And it also, the most stable isotope has steel half of almost 7.6 seconds. Very radioactive. And this is formed again by bombarding bismuth with iron. But this time bismuth with iron. Earlier it was lead with iron. This is bismuth with iron. Bismuth with iron. You see almost same process to form in the same lab. Okay, and this is named after the physicist actually, Lise Meitner. So on his honor, this Meitnerium name was given. Also, since they are very, very small T half, not much known is about the chemical properties of these elements. Dubnium. This has the most stable has a T half life of 11 seconds. Okay, this was again synthesized in 1994. So we don't say discovered, we say created for these elements. No natural isotopes occur for these elements. This was also done in the XII lab at Darmstadt. And since it was created in Darmstadt, the name Darmstadium is given. This was again created by bombarding lead, that is 208 lead, with accelerated nuclei of nickel 62. So by this reaction it was synthesized. The next is Rhodium. This also, if you see, is all synthesized in 1994. This was also synthesized in the XII lab in Germany, right? It is named after physicist Wilhelm Röntgen. Okay, this guy was a discoverer of X-rays, and this was again discovered by bombarding bismuth 209 with accelerated nickel 69. So you'll see most of these elements are discovered either in America, mostly in California, Russia, Dubna place, or XII lab, Germany. 3 of these places has given most of these radioactive elements. They are all synthesized. Copernicium. This was again synthesized in 1996 by again XII lab in Darmstadt. T half, the most stable is 29 seconds. And this is named in the honor of astronomer Nicholas Copernicus. You must be knowing this Copernicus, right? This is a very famous astronomer. And this copernicium was produced by firing accelerated zinc 70 nuclei, and this was targeted at lead. So lead 208, it was being fired with zinc 70 accelerated nuclei, and with this the copernicium was formed. So that's all about these metals, D block metals, overview of all these D block metals, how they look and what are their properties. With this, thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.